Welcome to Saxon Math Lesson 21. Today's math target is that we will be drawing triangles, rectangles, squares, and circles. So if you enjoy drawing or doodling of any kind, then this is going to be a very enjoyable lesson for you, most likely. If you are following along in your math book, I am on page 87, and about halfway down page 87, it introduces today's new concept. So as I said, in this lesson, we will be practicing drawing triangles, rectangles, squares, and circles, geometric shapes. That's the focus of today's lesson. So let's look at example 1. Let me click on my highlighter. Those of you that know me really well know I love my highlighter. Draw a triangle whose sides all have the same length. Okay? So first of all, we're going to be drawing, and let's break this question down, this problem down. First, it has to be a triangle, and you know a triangle has 3 straight sides, and all the sides have to have the same length. And there's a special name for a triangle where all the sides have the same length. That's called an equilateral triangle. So what you might need to do is practice on some scratch paper at first to understand how to draw a triangle where the sides all have the same length. It's not as easy as it sounds because what a lot of people want to do is they want to start off by drawing this corner. They draw a line down and then they draw a horizontal line and they think, oh, I'll just connect these two. And if you did that, you'd end up with a triangle that looks like this. And it certainly is a triangle. It has 3 straight sides. However, this side right here, it's longer. It's just slightly longer, not a lot, but enough to count. It's slightly longer than the other 2 sides. And remember, we have to draw a triangle where all the sides have the same length. That's the challenge today. So what you would do instead of starting off with a big L shape corner, you're going to want to draw a triangle whose sides are the same length. And so you're going to want to start with the base, the bottom leg of the triangle. And then you would measure that. Let's say it's 1 centimeter. Let's just pretend there. We're in pretend math world. And then you're going to take your ruler and you're going to connect the edge of this, the point right here, and you would draw another leg 1 centimeter and then 1 centimeter. And then you would double check your measurements to make sure that all the sides of the triangle have the same length. So like I said, that's called an equilateral triangle. Let's turn the page in our math book to page 88 and let's look at a second example. Example number 2. This time instead of a triangle, we're going to draw a rectangle whose sides all have the same length. Very similar to what we just did, but this time we're going to be drawing a rectangle. Now a rectangle is a 4-sided polygon. It has 4 sides and it has square corners, just like this. Let me show you. Here's 1, 2, 3, 4 sides, and here's a square corner. If you were to tuck a piece of paper into this corner, it would fit perfectly. But a rectangle does not always have to be longer than it is wide. In fact, a rectangle whose sides are all the same length would look like this right here, and you probably recognize that. You wouldn't necessarily have called it a rectangle at first. You probably would have called it a square because that's what it is. It is a square. It's also a rectangle. It's both because a square is a special kind of rectangle. Now, a square is always a rectangle, but a rectangle, it's not always a square. And in a few lessons, we'll learn more about rectangles and the different varieties there are. But for today, if it asks you to draw a rectangle whose sides all have the same length, well, you know if it's 4-sided and it has the same length, that's called a square. Let's scroll down to look at example 3. Now we're going to be asked to draw a rectangle, but this time the sides are not the same length. We want to draw a rectangle that is 3 centimeters long and 2 centimeters wide. So what does that mean? Well, that means that the length is going from side to side and the width is going up and down. That's the width. So here they're going to use a centimeter ruler to help make sure your measurement or your drawing is accurate. So you'll see that 3 centimeters long. Let me go back and color code this. I think sometimes color coding helps. And let's choose the pen, the red pen. Okay, so length is going to be represented with red. And you'll notice that it is 3 centimeters long. 1, 2, 3. That's the length that I just traced in red. And then this is also the length. So when you draw horizontal lines, that's the length. Now it wants us to also draw the width, 2 centimeters wide. So the width is when you draw from top to bottom or from bottom to the top. So let's see if I can get my pen to work here. And so if it's green, that's the width. That's how wide it is. Oh, that worked lovely. And let's change that to red. And this is the length. L-E-N-G-T-H. That's the length. So when they ask you to draw a shape with a certain dimension, 3 centimeters long and 2 centimeters wide, you would need a ruler. And then you would draw the length horizontally and the width vertically. Okay, let me switch back to the mouse mode and we'll continue looking at examples. Now, to draw circles, we're going to need a tool called a compass. And below you see 2 different types of compasses you might have in your classroom. This is the standard or traditional compass, and this is called a safety compass. So you might have both in your classroom. Now there are 2 points on a compass. Okay, there's the pivot point, and then there's the pencil point. Okay, so one side is the pencil. Here's the pencil point here, and on the safety compass, your pencil point would go either in this hole or that hole. That's where your pencil would go. And then the pivot point, this is what stays in one location and the compass circles or pivots around it. This is your pivot point on the standard or traditional version, and this is your pivot point. This is where your finger or your thumb would go and it would hold the safety compass still, and this part would swing around. And then the same, this is your pivot point, it would hold still, and your pencil point would swing around. So you swing the pencil point around the pivot point, say that 3 times fast, to draw a circle. All right, so what am I getting here? Well, the reason I want you to know that is because the distance between the 2 points is called the radius of the circle. Radius. Now this is a math term you're going to need to know. The radius of a circle is the distance from the center of the circle to the circle. So the outside edge of the circle. And if we're talking about more than one radius, the plural version is called radii, and it's got those 2 eyes on the end, just like you have 2 eyes. Radii. So remember, the radius is from the center point out. So let me see if I can get my shapes up here. Here they are. And let's just draw a little circle. Boom, there we go. And let's get my pen back. So this would be the center point right there where that red dot is. And the radius is from the center of the circle out to the edge. The radius could be out from that side, but it doesn't have to be. The radius could be from the center to this edge, although it would be a lot straighter. Let me go back here and choose the line feature. Yeah. So the radius would be from the center to that edge. It could be from the center down. It could be from the center out and up. Okay, it's just anywhere from the center out to the edge. And the plural is pronounced radii. So turn in your book to page 89, the next page, and let's look at this example. It's example 4. It wants us to draw a circle with a radius of 2 centimeters. Now this is why you need to know what a radius is. You need to know when you see the word radius, you think, oh, that's from the center out to the edge. From the center out to the edge. That's 2 centimeters, just like they have that labeled there. So you place the pivot point here where this black dot is, and then you would swing the pencil point all the way around, and you might need practice at this. Most of my students generally do need a little bit of practice at swinging it without moving your paper. You could also have a friend hold the paper still. That's very useful. Sometimes when you're first learning to use a compass, it helps to have maybe instead of just 2 hands, 3 or 4 extra hands. So you would swing the pencil point of the compass around, and this would be a circle with a radius of 2 centimeters. Now another geometric term I want you to learn is diameter. The diameter of a circle is the distance across the entire circle, straight through the center. So let's draw our line right here. And let me make it red so it really shows up. Your diameter is from one side straight through the center to the other side. That's the diameter. I'm going to underline it so you know that's the diameter. Side to side, straight through the center. You can't, that's not the diameter because it's not going straight through the center. So let me get rid of that. The radius, let's change color. Let's make it real obvious green. The radius, remember, is from the center out to the edge. So it takes 2 radii to make 1 diameter. Oh, that's pretty good. Let me write that down. I'm going to pick up my pen here. It takes radius, which is like half the circle, plus the other radius, that equals the diameter from side to side. And you just have to memorize those terms. The diameter from side to side straight through the center, and then the radius from the center out to the edge. The reason you need to know those terms is because you might see this type of question in your assignment. If the radius of a circle is 2 centimeters, okay, so that means if, let me change pens to green. So if the radius is 2 centimeters, says the question, then what is the diameter of the circle? Well, remember, radius is just half, 2 centimeters. If this radius is 2 centimeters, then this radius also must be 2 centimeters. And if you add 2 plus 2, then you get a diameter of 4. 2 plus 2 is 4 centimeters. So your diameter would be 4 centimeters if the radius of a circle is 2 centimeters. Okay, if you look at the bottom of page 89, there are some practice problems for you to draw. For some of them, you'll need a ruler. For others, you'll need a compass. But I would encourage you to practice drawing these shapes, triangles, rectangles, squares, and circles until you've mastered them. I'm sure you can do it.